Now let's go to, I did the transpose, let's go to question 2. What I want to do is I want to calculate average monthly returns. I can do this. It tells me to go through to AD6 to ES6. So I'm going to go to average, simple monthly returns, and it says 86 to ES6. So 86. And if you notice here, once I go, can you see the gray boxes that appear that tell me I'm in cell 86? I'm going to scroll to the right. Close parentheses. So if you notice, I selected this myself. You can type it in, but I think it's better practice to learn to use this information. Now, when I highlight this, if I go to the formula bar, when I highlight this, I can see the information that I have highlighted. Okay. So now, why are we using, we can use either one of the tables. We can use the transpose data, as here, or I could also use this data. But why am I doing this? Because I have, well, the spreadsheet has this table where the data for each of these stocks, the returns are in different rows. So now I can drag this formula and calculate these returns based on this data. If I go to next cell or the cell after that, notice that I just drag and then calculate these returns. Now I can do the same thing with standard deviation. So remember, we talked about 2 different standard deviation formulas. They both get to the same point. We talked about the standard deviation formula, which is basically you take all observations and you use STD EV formula, open parentheses, and it tells me ADES6. Well, what do you know? It's ADES6. It's just standard deviation of the same asset. Those are our first 2 descriptive statistics that describe that data. The expected return, which is the mean of observations based on the past data, and the standard deviation of these returns. How much did they vary over time? Now, the other way we calculated standard deviations that we've studied recently is we took weighted average of the standard deviation given a state of the economy. Now, the way these states of the economy are calculated is you take these observations and look at the expected return during those states of the economy, for example, the recession, and the economists look at the probability of that expected economy, and you simply multiply the probability of the state of the economy times the expected return during that or given the state of that economy. If you have had the same data set, you would get the same result. Sometimes we simply have the probabilities and the summarized returns given those probabilities, or sometimes if we have the raw data set, we can calculate standard deviation using the basic statistical formula. Now, what are these 3 columns here? These are very helpful, and you will see in further tabs that they can be used in variation of estimating returns. Why? The average past returns is a good way to summarize past observations, but there is a bias to it. Because if we have, for example, for this stock Barrick Gold, using past returns assumes that the future returns are going to be similar, okay, with within some range, the confidence interval. If we look at the capital asset pricing model that we are going to cover very soon, or the FAMA French 3-factor models, we can look at different ways to price these assets or calculate the expected returns. And if we look at different ways of calculating this, we can have a better idea of the range where these observations would fall. Look at what happens. The average past returns estimate that this stock would return 1.35%, whereas the CAPM only estimates 0.46%. So there's some variation there. Oftentimes we look at different methods and we look at the median, the middle observation. But let's go on with these descriptive statistics for now. Okay, so I'm on question 2. Let's go and see what's next. Number 4 is here the correlations, which we derive from covariances. But at the same time in Excel, you simply can type in the correlation formula. But what I'm going to do is I'm going to go see, okay, number 3. Oh, actually, this is number 4. So we did number 2, number 3. Now we're going to number 4. So to calculate the correlations, this is why we actually need this matrix the most. What we can do here is we will enter Corel. This is our formula for correlation, and it's asking me for array 1 and array 2. These are vectors or tables with information for my specific stocks. In fact, the information is just the returns. So when we calculate correlations, we take covariance and we take standard deviation of each of these arrays. But in Excel or any kind of data analysis software, we can simply use the returns because the covariance and correlation and standard deviation are all based on these returns. So what are we doing? The first array it's going to tell me is B6 to B125. So I'm going to go to B6 through B125. So I'm going to go B125, B6.25, okay, comma, and let's go back.